In this video, we'll understand about planar graphs, orientation, and tournaments. What are these concepts? First, planar graphs. A graph is called planar if it can be drawn in the plane without any edges crossing. Such a drawing is called a planar representation of the graph. Now, let us understand regions in the planar graphs. The planar representation of a graph splits the plane into regions. These regions are bounded by edges except for one region that is unbounded. Regions are also called as faces. Each region has some degree associated with it and is given as degree of interior region is number of edges enclosing that region. Degree of exterior region is number of edges exposed to that region. So here in this graph, we may notice there are vertices A, B, C, D, E, F, G. These are the vertices and edges 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And we may notice the regions are R1, which is this, then R2, which is this, R3, this one is R3, this one is R4, and this one is R5, and the outside, this is R6. So here R1, R2, R3, R4, and R5 are all bounded regions, and the R6 is unbounded region. Degree of R1, we may notice it is 3, right? R1. And then degree of R2, we may notice it is again 3. Degree of R3 is also 3. Degree of R4 is also 3. And degree of R5 is also 3. Whereas degree of R6 is 7 because 7 edges are exposed to it. Then what is Euler formula? For any planar graph with V vertices, E edges, and R regions, we have V minus E plus R equal to 2. In the above planar graph, we may notice there are 7 vertices, 11 edges, 6 regions. So we have V minus E plus R, which is 7 minus 11 plus 6, which is 2 only. This is applicable, this Euler formula is applicable for all planar graphs. Question: what is the number of regions in a connected planar simple graph with the 20 vertices, each with degree 3? So sum of degrees of vertices means it is 20 times 3, which is equal to 60. And that is nothing but 2 times E. So based on the handshaking lemma, what we had seen earlier, therefore E is equal to 30. Based on Euler's formula, we have V minus E plus R, which is 2. That means 20 minus 30 plus R equal to 2, which means R will be 2 plus 10, and that will be 12 regions. Then some of the properties of planar graphs. If a connected planar graph, capital G, has E edges and R regions, then R will be less than or equal to 2 by 3 times E. That is one property. Second property, if a connected planar graph G has E edges and V vertices, then 3V minus E should be greater than or equal to 6. A complete graph K suffix N is a planar if and only if N is less than 5. A complete bipartite graph K suffix Mn is planar if and only if M is less than 3 or N is greater than 3. If any planar graph having E edges, sum of degrees of all the regions is 2 times E. So these are the properties of planar graphs. Now let us understand orientation of a graph. In a graph theory, an orientation of an undirected graph is an assignment of a direction to each edge. Means an undirected graph, by marking arrows, it becomes a directed graph. That we call it as a orientation, turning the initial graph into a directed graph. An orientation of an undirected graph G is an assignment of exactly one direction to each of the edges of G. A directed graph is called an oriented graph if none of its pairs of vertices is linked by two symmetric edges. In simple words, an oriented graph is an undirected graph with orientation. So this is an oriented graph. B to A it is going, C to A it is going, B to C it is going. This is strongly connected B-oriented graph because A to B and then B to C and then C to E. This is not strongly connected since there is no path from A to B, A to C and C to B. A to B there is no path, and A to C there is no path, C to B there is no path. Even if you go in different direction also, you don't find this path. Whereas this is a strongly connected graph because from A, I can go to any of the vertices. From B also, I can go to any of the vertices. There is a connection. Then comes tournaments. When you say complete graph, it is a simple undirected graph in which every pair of distinct vertices is connected by an unique edge. Oriented complete graph, we call it as tournament. And what is that? It is a graph in which every pair of vertices is connected by a single uniquely directed edge. Hence, a tournament is a digraph obtained by assigning a single direction for each edge in an undirected complete graph. The name tournament originates from such a graph's interpretation as the outcome of a round-robin tournament. It's a game which is being played in which each player encounters every other player exactly once and in which no draws occur. Means somebody will be a winner and somebody will be a loser. There will not be any draw. In the tournament digraph, the vertices correspond to players. The edge between each pair of players is oriented from the winner to the loser. If player A beats player B, then it is said that A dominates B. If every player beats the same number of other players, that is in degree is equal to out degree, the tournament is called a regular tournament. So a tournament on 4 vertices. Here it is an example. 1, 2, 3, 4. These are the vertices. And here the edges goes like 1 to 2 and then 2 to 4 and then 4 to 3, 3 to 1. Then we have 1 to 4, 3 to 2. This is an example of tournament with 4 vertices.